let's look at a hypothesis test for comparing means of two independent groups. Who talks more, men or women? One researcher fitted men and women with a voice recorder that recorded 30-second snippets of speech every 12.5 minutes throughout the day, then extrapolated to estimate the number of words spoken per day. Here are the results. So again, Y1, number of words spoken per day for a man. Y2, number of words spoken per day for women. On average, men spoke 15,669 words. Women spoke 16,215 words. Is that enough of a difference to conclude that women speak more than men? Let's find null and alternative hypotheses. As always, the null hypothesis, no difference, they're the same. Men, women speak the same number of words per day. And it would be of the form mu1 equals mu2. The alternative hypothesis would be that there is a difference, and it would be of the form mu1 does not equal mu2, or mu1 is greater than mu2, or mu1 is less than mu2. So our null hypothesis is men and women use the same number of words per day. If we wanted to state that using mathematical symbols, it would simply be mu1 equals mu2. Our alternative hypothesis is that mu1 does not equal mu2. We choose this as the alternative hypothesis because we want to test the hypothesis that men and women speak the same number of words. We weren't told that we want to test the hypothesis that women speak more or men speak more. We're just told test the hypothesis that they speak the same number of words, so this is how we choose the alternative hypothesis. Okay, so there's how we define Y1, Y2 are null and alternative hypotheses. We want to do a hypothesis test to compare the means of two independent groups. Do the data satisfy the required conditions? Here are the data. Random sample from each population, or you could randomly assign people to each group. Well, in this case, we didn't randomly assign people to be male and randomly assign other people to be female. Instead, we took a random sample from each population. Random sample of men, random sample of women. The distribution of the data has to be nearly normal. When each group is less than or equal to 15, this is what you're looking for. When each group is between 15 and 40, this is what you're looking for. And when each group is greater than or equal to 40, which is what we have, you're just looking for data that are not extremely skewed. You also need independent groups. It's not as if each subject from one group is matched with or related to a subject from the other group. So these are presumably independent groups. The men are independent of the women. Okay, so there's null and alternative hypotheses. Calculate the test statistic T. By the way, the denominator of the test statistic is called the standard error, or the standard error of the difference, and the book represents it by SE, or SE of y1 bar minus y2 bar. So what's on the bottom here, including the square root? That's standard error. Okay, so we plug in the numbers. Y1, 15,669. Y2, I should say y1 bar. Y2 bar, 16,215. Plug in the standard deviations. And the sample size is 186 men, 210 women. Plug all of that in, and you get T equals negative 0.6749. Use a graphing calculator to determine whether we should reject or fail to reject H0. Now there are ways that we could actually use a table to determine whether or not we should accept or reject the null hypothesis, but to be honest with you, it's just easier to use the TI, so let's go ahead and do that. Okay, so we'll go over this and I'll show you how this works in a moment. What we do is we press stat tests to sample t-test because it's t-test and we have two samples. In this case, it's men and women. Now, your input can be data, if you already typed all the raw data into the TI under the stats, or you can just enter stats if you know the basic statistics already, like the sample mean, sample standard deviation, sample size. That's what we'd enter. We'd enter those. Choose pooled if you believe the population standard deviations are close to each other. If, say, the higher sample standard deviation is less than twice the smaller one. Otherwise, choose not pooled. You'll see in a moment what I mean by this. Okay, there's our data. Let's enter it. Okay, so turn on the TI and let's choose stat. Okay, tests to sample t-test. So again, we would choose stats because we don't have the raw data. And you just enter everything here. X1 bar, 15,669. The standard deviation is 8633. And the sample is, N1 at least, that first group is 186 men. Sample mean, sample standard deviation, sample size for the women, scroll down. That's how we choose our alternative hypothesis mu1 does not equal mu2. Pooled? Yes, we're going to choose pooled because it looks like one standard deviation is about the same as the other. Now, if one is more than twice the other, then you wouldn't pool them. But otherwise, we would pool them. We pool them because we're assuming that the standard deviations are the same. And we're just grouping them together so we can get a better estimate of the common, the pooled sample standard deviation. Or actually the pooled population standard deviation. Okay, and then we press calculate. Bam! There we get it. So t equals negative 0.6817. This is cool. Look at this. P-value is 0.4958. Ho-ho! You know what that means. If the p is low, the null must go. So we're not going to reject. We're going to fail to reject the null hypothesis. Now note that this t value is slightly different from what we found, and that's because we pooled it. If we had not pooled it, we would have gotten what we got just calculating it a little while earlier. This is something else too that's cool. Check this out. You can actually, what's really neat too is if we do this again, hang on, you can actually get this cool graph, two sample t-test. So check this out. If instead of choosing calculate, you had chosen draw, it will draw this for you. And so again, here's what this means. Notice the p-value is 0.5 roughly. That's because this area altogether is 0.5. That's the probability that you get a result this extreme or even more extreme than what we got, if the null hypothesis is true. Okay, so this is what we end up with. T equals negative 0.68. P is greater than 0.05. We fail to reject the null hypothesis. Okay, that's what we found for the p-value. We don't reject. We fail to reject. When the p-value is much greater than 0.05, this is what we say. There is not sufficient evidence to conclude that, and then we state the alternative hypothesis. So in this case, there is not sufficient evidence to conclude that men and women use a different number of words per day. So it seems that men and women, on average, speak the same number of words per day. Suppose that our decision turns out to be incorrect. Have we made a type 1 or type 2 error? Okay, here's what's critical. We failed to reject the null hypothesis. So if that decision is wrong, if we were incorrect, we shouldn't have failed to reject the null hypothesis. Instead, we should have rejected the null hypothesis. So in other words, H0 must have been false. So if the decision to fail to reject is a bad one, that means H0 is false, and we should have rejected it. If H0 is false and we fail to reject it, we've committed a type 2 error. This is failing to reject H0 when H0 is false. Use a graphic calculator to find a 95% confidence interval for the difference between the mean number of words spoken per day for man and the mean number of words spoken per day for woman. Okay, so what we'll do is, as before, choose stat, tests, 2 sample t interval, press enter. Again, this time it's 2 sample t interval. So make sure you do that. Make sure you do that on the TI. Okay, so check this out. So we turn it on, stat, tests, 2 sample t interval. Okay, we've already put in the data. In fact, it's already in there. So we just scroll down. Okay, the confidence level, 0.95. That's what we want. Pool data. Yes, we're going to pool it. And then calculate it. Bam! There's your confidence interval. So your confidence interval turns out to be negative 2121, comma, 1028.6. That's your confidence interval. Very cool. Okay, so a 95% confidence interval for the difference between the mean number of words spoken per day for a man and the mean number of words spoken per day for a woman is negative 2,121 to 1028.6. Give a proper interpretation of the 95% confidence interval. There is a 95% chance that the difference between the mean number of words spoken per day for a man and the mean number of words spoken per day for a woman lies in the interval negative 2121, comma, 1028.6. That is, assuming the null hypothesis is true. By the way, the extremes in the study were both men. One man spoke an estimated 47,000 words per day, that's 3 times average, while another man spoke an astonishing 795 words per day. For comparison, the average English speaker speaks 150 words per minute, so I exceeded his daily word total in the first 6 minutes of this video.